Hey, come in.
Thanks. Do you know, Doc, I think it's all a matter of semantics. All that concern you have about me and my regaining my faith in science, I don't mean that I'm going to fall on my knees and worship it. You know, I don't think science is a god, and nor do I think it's infallible. I just feel like I am a little less cynical than I was at the beginning of the play, and that's a good thing.
What play? Davies.
Yeah.
Yeah, I think it's a good thing you're not cynical too.
Yeah. So,
We've got a party happening.
oh, of course. What time are they arriving?
Oh, I don't know, any minute now.
Okay. Hey, do you know, these people out here who've been watching all this, I think it's a bit of a pity that they haven't had a chance to interact with our ideas, you know?
I'm not interactive theatre. I hate interactive theatre.
Oh, you don't attack the front row, except for the rooster. You don't attack the front row, you focus on the people behind. Sorry. Okay, I think I'm just going to see if they've lost their way.
It's nearly time for the
party.
party.
Anne-Sophie, it's over here.
Hint.
It's over here, Anne-Sophie. Oh, hi, you can enter through either door. Either door. It's all careful. Either door. Please come in. Welcome to our
Come on in.
home.
Got a glass of water?
Oh. All right then. So, you know, there's something else I need.
Finally getting.
Oh, there's Mr. Noble. Thank you. This is a third doorway.
That's the window, isn't it?
Okay then. So, can I ask, does anybody have any questions for our wonderful scientists? I think you had one earlier.
I did. This is for the immunologist in the middle.
That's for you, Harry.
Okay. Harry. I wanted to get some clarity on the discussion between yourself having a cold and the influenza vaccination, when I thought they were quite different in terms of one, like a cold being different from the flu virus.
Okay, so a cold is different from the flu virus.
That's true. So the common cold is caused by lots of different things. So some people will go to the doctor and get antibiotics for a cold, and sometimes it's bad by the doctor that gave you antibiotics because that cold will be caused by a virus instead. But there's
I beg your pardon.
I'm
There
sure
could have been an antibacterial component, and he was in the danger zone for the flu.
could be, but I think most people will know if you've got the flu knocks you out much more than the cold, I think. So the flu is definitely a different, influenza, which is the virus that causes the flu, is definitely a different disease to the common cold. I think that was just artistic leeway. But
Yeah, well, I mean,
know an immune system.
I do think it's interesting though, because you know I go to the doctor sometimes. Well, actually, from now on. Well, when I have a cold, how do I know myself, or how does the doctor even work out? Okay, well, whether this is bacterial or viral, is it the green phlegm?
generally, as far as I'm aware, again, I'm not a doctor, so this is outside of my field, but as far as I'm aware, unless there's a doctor in the crowd who can tell me otherwise, they don't really know. Bacterial infections, I know, sometimes last longer, and so...
Fever?
Well, they can look basically the same, so it can really just depend. Okay. I think that you'll get better eventually.
Have you got a question?
On the same note that you were saying, I heard once you have a cold, like I went to the doctor with a cold and then they said, no, it's too late for you to have the flu shot. Is that correct?
The flu shot is if you've got a lowered immunity. If you're in the danger zone, then that's when we give you a flu shot. Obviously, it's not going to stop a cold, but like Harry said, it's seasonal as well. So if you've missed the wave, we should get away from these doctor things because we don't actually have any real doctors here.
They're researchers.
I have one. So if our flu vaccine is based on flu, what's the Northern Hemisphere flu vaccine based on?
What we get sick with.
Really?
So it sort of, as far as I'm aware, they track what. So our flu vaccine will stop 80% of the flus, but the 20% that get through will be then the ones that the northern hemisphere will then look at. So that's why it's seasonal, because it sort of tracks across both hemispheres.
Okay. Does anybody have any questions about GM or something else?
Not about this.
What's your question?
I had a question kind of to everyone about all these sort of things that are sometimes considered controversial in the public space. Is how important is it that lay people understand sort of the basics of the science versus how much of it is important that we just kind of trust in the experts?
Oh, that's a really good question. Who would like to take that one? You can go. Nerilie, over to you.
So I think there's a strong role to play there in people being scientifically literate, but we certainly can't expect everybody to know everything about science, and I certainly don't know very much at all about immunology or about GM, but I can also understand sort of the scientific method, and I can also understand sort of who experts are and who I should be trusting, and that if there are experts from a university who have studied in that area and are telling me information, then I should trust that as opposed to something that I'd read just on Google.
I think Google's brilliant. Oh, we've got a question down the back.
Yeah,
you got one first?
just wanted to say as well, that's
Robin,
probably
you're
why
next.
it's so important that we make sure that scientists talk to people instead of being in their own little bubbles just with scientists, because it's very comfy, but it's sometimes a bit boring. And I guess it's very important that we make sure that we talk about what we do with people. So we don't have this feeling that, you know, the crazy scientist wearing lab coat, just doing crazy things.
I'm a doctor.
Okay, thank you very much. Down here.
No, it wasn't.
Here we go.
Nerilie, you got a little bit sidetracked when someone asked you, do you believe in climate change, and you said it's not a case of believing in it. Can you unpack that a little bit more?
Yeah.
Oh, let me take that. Oh, there we go.
So I guess the analogy would be if somebody asked me if I believed in gravity, and I said no, I don't believe in gravity, that doesn't mean that I'm just going to float off into space. So there are certain things about science. So there's the process of science, and so scientists look at the world. They come up with ideas, and some of those ideas stand the test of time, and those are the actual, true, unequivocal bits of science. But scientists are also pushing the boundaries and trying to discover new things all the time, and some of the things that the ideas that we come up with, some of those will be the truth, and some of those will turn out to actually not be correct, and that's the scientific process. As we gather more evidence and we do more research, the things that are actually the true way that the world works are the things that will stay with us.
And is that the peer review process?
Peer review process is part of that, but it's also just lots of scientists in lots of different laboratories all approaching this problem from different avenues. And so for something like the unequivocal warming of the world that we see, that's unequivocal because lots and lots of people have come up with that same finding from multiple lines of evidence, and every way that we look at that problem, that's the only answer that we get.
Those thermometers are just a lie.
Okay. Oh, we have one more question, but how many more questions do we have time for?
3.
3 more questions? Thank you.
So people were predicting the warming of the planet and tsunamis and various things, and we didn't take much notice, and now we do. Now we accept generally, perhaps, that, as you say, there are people, even scientists, who have come together and said, yes, this is true, is happening. Are there other things that you clever scientists have been predicting? Can you tell us any more things that are coming along from climate change, and what source could we go to find that out just day to day ourselves? Thanks.
Great. Thank you very much. Excusez-moi. Did you want to take this one?
I can
Okay.
see
All right.
So one area of climate science that we're still doing a lot of work on is trying to understand how quickly sea level will rise and what impact that will have for different people around the world. And And the reason that we don't know the answer to that very well is that we don't understand fully the physics of how ice sheets work. How quickly can an ice sheet actually disintegrate and move into the ocean, and how quickly are the oceans around Antarctica warming? We don't understand the physics there well enough, so we have a large uncertainty. We know that the oceans are rising and they will continue to rise, but we just don't know exactly how quickly that will happen. So we have a range of possibilities that we give to people who are planning coastal defences. In terms of that information and how we get that to the public, there are actually a lot of good resources. So one is a site called Coast Adapt, which is developed by the CSIRO, where you can actually go and look for every coastal council around Australia. You can go and look at what the predictions are for different scenarios as to how quickly sea level rise, and then actually see the maps as to which areas of land will be inundated in 30 years' time or in 80 years' time under different scenarios. So you can actually go and see that information for yourself as well.
In terms of science in general, one of the very good options, I would say, for information would be here, the Australian Academy of Science. So they put together a lot of information about climate change, for example, but other things as well. And it's actually, it's proper science, but explained in a way that everyone can understand it, so you get rid of all the jargon that can be terrible. And it's actually really useful. So they are very good sources of information here.
That's science.org.au.
Exactly.
And the American Association for the Advancement of Science is also another fabulous resource.
And the New Science.
And New Science.
New Scientist. Oh, and TV Week.
Sorry, I forget your name. So, what would you say to the people who say that there's a much more complex relationship between genes than might be a popular understanding of genes, in that, like, a particular gene may code for several different characteristics, or many genes may code for one characteristic, so cutting and pasting genes may have a lot more unintended consequences than we think, particularly in an age of CRISPR, and with regulation of CRISPR not really being ahead of the research into that.
Cut me out.
Doctors, we don't need them. So basically, that's a very good question, and I won't go too much into details because I'm not a specialist of this, but that's something that is really heavily studied. So, for example, so there is, at the moment in Australia, nothing has been, as far as I know, tested out in the field, for example, that has been using CRISPR to be modified. But there are labs working on this kind of area, and no matter what, if you want to do anything, so in terms of plants, if you want to just see out in the field what these plants are doing, you have to provide so much information about how your plant grows, how it reacts. So you basically have a massive lot of characteristics that you need to just check to make sure that the plant that has this modification doesn't have unattended modification that you weren't expected. So there is, what I can tell you here is that there is really a lot of work that is done to make sure that there is no issue with this. And basically, if I can say this as well, I guess that when we talk about GM, we actually, what we do is much simpler than what people think in general, because we, I know that some, for example, some people are trying to put a lot of genes together to try and build things. I have, I know people in the US at Harvard Medical School who are trying to produce new structures in bacterial cells because it could be helpful in terms of medicine, but it doesn't work. So, so far, maybe one day it will, but basically it's so complicated that we're not able to reproduce complex mechanism. So we, at the moment, as far as I know, it's mostly simple things, at least for plants. But again, there is a lot of regulation around this to make sure that nothing bad happens.
So what is genetically modified in
That's the
in
last
Australia?
one.
Thank you.
What's genetically modified in Australia?
So basically, in terms of commercial plants that are genetically modified, so you will have cotton. So about 90% of the cotton that is grown in Australia is genetically modified. You'll say that's fine. And so keeping in mind that basically what you're wearing here doesn't have DNA, it's just cotton fiber, so there is no DNA in it. There is so it's not considered as being GM anymore because there is no genetic information in it. But yeah, so it's basically because it helps farmer with growing the plants because they're resistant to they can use pesticides and things like this. The other GM plant that we have commercially here is canola because it's resistant to some herbicides. But the thing about this is that sorry, I'm going into facts now. It's too late to not be a scientist. So basically, so the canola that's grown here in Australia, so 20% of it is GM, but about 80% of canola grown here in Australia is resistant to herbicides. So basically about 60-ish% of this canola is resistant to herbicides, but without being GM. Just because plants can be resistant to many herbicides, and basically that's been used. So yeah, so long story short, there are two kind of plants that are genetically modified here in Australia, and we use them. Yeah, but
so when people say
Okay,
GM free,
wind it up, Phil.
it's actually all GM free anyway. What a line. All right. So, but nobody's asked us any questions about poetry.
Well, how about this? So poetry is the thing that answers the questions between the science.
Nice quote.
Thank you.
Whose is it?
Oh, right.
You're right. If we knew everything, there'd be nothing left to live for. There's some things we just can't know, and that's fine.
Poetry and science. Do they go together?
I think poetry helps science. Science helps poetry.
I think they go together.